Hi everyone, I am Ranjita. Today we are going to discuss about the mathematics 3. In that we took a topic about Z transformation. What is meant by the Z transform? The Z transform is a mathematical tool used in a field of signal processing. It is a discrete time equivalent of the Laplace transform. It provides the way to analyze and manipulate discrete time signals and systems. Applications of Z transforms. The field of a signal processing is essentially a field of signal analysis in which they are reduced to their mathematical components and evaluated. One important concept in a signal processing is that of the Z transform, which converts the unwieldy sequence into forms that can be easily deleted with Z transform or used in many signal processing system. The Z transform can be used to solve differential equation with constant coefficients. And definition: the Z transform converts the discrete time signal or system from the domain to the Z domain. It is defined as the power series representation of discrete time signal or system. The Z transform can be used to solve difference equations, analyze a stability, and determine determine a frequency response. Region of convergence. The region of convergence is a set of complex number for which the Z transform converge. It determines the range of the value for which the Z transform is valid. The region of convergence can be inside or outside the unit circle in the Z plane, depending on the properties of the signals. Inverse Z transform. The inverse Z transform is used to convert a function in the Z domain back to the time domain. It is denoted by the x into n is equal to 1, that is 2 pi x integral x of z into z power n minus 1 into dz, where the integration is performed along a closed path in the z plane. The inverse Z transform allows us to obtain the original discrete time signal from its Z transform. In this, we can see the inverse Z transform, that is x of a is z is equal to 8z minus 19 divided by z square minus 5z plus 6. In this, we are going to apply the Z inverse formula and we're getting a minus 19 by 6 u of n plus 3 by 2 and 2 to the power of n plus 5 by 3 and d to the power of n into un. Next, we are going to discuss about the Z transform poles and zeros. The poles and zeros of the Z transform are the values of Z from which the Z transform becomes a initiate or zero respectively. The poles and zeros provides important information about the stability and behavior of a discrete time system. The location of a poles and zeros in the z plane determines the frequency response and the characteristics of the system. Properties of the Z transform: linearity. The Z transform is a linear operation, which means that it satisfies the superposition principle. Time shifting. The Z transform of a time shifted signal is obtained by multiplying the original Z transform by Z raised to the power of the time shift. Convolution. The Z transform of the convolution of two signals is equal to the product of their respective Z transforms. Advantages of Z transform. The Z transform allow us to analyze and design a discrete time system using a mathematical techniques. It provides the frequency domains representation of discrete time signals and system. The Z transform is com- computationally efficient and can be implemented using a digital signals processing algorithms. Keywords: Z domain, the domain in which the Z transform operates are representing the complex plane. Z transform functions, the function used to represent a discrete time signal or system in the Z transform. The region of convergence, the set of values of Z for the which the Z transform converts. Applications, that is digital filters, the Z transform is used to design and analyze the digital filters such as the low pass, high pass, and the band pass filters. Control system, the Z transform is used to analyze and design a discrete time control system. The image processing, the Z transform is used for image enhancement and comparison and the filtering. Digital filters are CT step excitation in not an impulse. So, what should the correspondence between the CT and DT extensions be now? If the step execution is sampled at the same rate as the impulse response was sampled, the resulting DT signals in the execution of the DT system and response of the DT system is the sum of the response to all those DT impulse. Problem one, we are going to take some examples. Give a discrete time signal x of n is equal to 1, 2, 3, 4, and find its Z transform. The solution: applying the Z transform definition, x of z is equal to 1 plus 2 into z power minus 1 plus 3 z power minus 2 plus 4 z power minus 3. And your third built, and we are going to take another example. The give a discrete time system with a transfer function h of z is equal to 1 minus 0.5 z power minus 1 divided by 1 plus 0.8 z power minus 1. Find its impulse response. Taking the inverse z transform of hz, the h of n is equal to 0.5 power n minus 0.8 power n. This is our third bit. Thank you, everyone.